welcome back to stately Pitcher Manor and my dining room. Today we'll be moving on to the next chapter, chapter 21, and we'll be looking at coordination chemistry. There's a bit of the chapter that I won't go into much detail or even go into at all. For example, the last section on metallurgy, I'm not going to talk about. But it's probably best to start out talking about transition metals and then work our way into coordination compounds. So that's what we'll do in this lecture. So transition metals are the weird part of the periodic table. Well, maybe not as weird as the lanthanides and the actinides, but they're the D block, that part in the middle of the periodic table. And they have some interesting properties. And they actually behave similarly chemically and have similar properties within a period as well as within a group. So similar within a period as well as within a group. Okay, and what else? Well, they are conductors. Co-ductors, conductors. They're shiny. Well, some of their other properties may vary. So we'll just say that here. Other properties may vary. And that's things like ductility, density, etc. So ductility is how easy it is to basically smush the metal. So something like gold is very ductile. You can hammer it into a really thin sheet, something called gold leaf, whereas something like tungsten would be very hard and not ductile at all. Now, they being the transition metals, also have, or they often have, say, multiple oxidation states. So remember iron could be 2+, it could be 3+. Vanadium has a whole bunch. I think manganese has a whole bunch as well. And so there's not necessarily a rhyme or reason. Typically elements at one end of the D block or the other have fewer. So for example, something like zinc is always 2+. But even within a period, you've got copper could be 1+ or 2+. Silver is always 1+. Gold could be, I think it's usually 3+. Meanwhile, next to gold is platinum, could be 2+ or 4+. So it really does kind of vary. And the other thing, and this is going to be the most important or interesting thing for this chapter, is that transition metals can form complex ions. I do apologize for that. We have a Roomba right next to me, so apparently I kicked it while I was lecturing. Anyway, let's take a look at these complex ions. And so I'll pause for just a minute. You can pause recording if you want to copy any of this down. Sorry. There we go. And let's take a look. Let's take a look at complex ions. And we've seen a complex ion before. And complex ions also fit into the category, hold on one second here, of coordination compounds, which we'll get to actually in just a little bit. So the best way, of course, to look at a complex ion is probably by drawing an example. So we could have CuNH3, let's have 6 of those, and that has a 3 plus. And now we could have a coordination compound which consists of a complex ion plus some counter ions. So in this case, it would be Cu hexaamine and then Cl3. Okay, so we've got again our complex ion. And those chlorides are counter ions. Now, what do these actually look like? Well, this is a rough model right here of the copper hexaamine complex ion. Okay, so I'll move that in a little bit closer. This in particular is an octahedral. So in this case, each green represents one of the ligands, and they're in this octahedral shape. So there's 4 around the middle and 1 above and below that middle plane. Now we can draw it in the following way. I can draw my copper in the middle, and then NH3 above and below. And then I'm going to use these wedges and dashes to indicate things that are coming out towards you and back away from you. So a wedge is coming out towards you, and dash going away from you. And that means the wedge is coming out of the plane of the board or a piece of paper that you're drawing on, and the dashes are going back behind the board. So what this guy is it is this. Okay, so again, I'll come up a little closer here. Hopefully you can see that pretty well. So these two, my fingers are on here, are coming out towards you. Those would be the wedges. And these other two that are going away would be the dashes. This is a formalism to indicate 3 dimensions on a 2-dimensional piece of paper. And it's used in organic chemistry all the time. Now, I'll pause here so you can write down what wedges and dashes mean. Again, wedges are coming out towards you, dashes going away from you. Okay, and I'm going to erase this just to maybe clear things up a little bit. this is our actual complex ion with a 3+ charge. And then we'll have 3 chloride ions, which are the counter ions. Okay, so complex ion plus counter ions makes up a coordination compound. And we will be talking about these for most of the this chapter. Actually, pretty much all of this chapter. A couple of other things to note before we talk a little bit more about coordination compounds. You can read about in sections 1 and 2, particularly section 2, 21.2, read about the first row transition metals and some of their properties. But I'm not going to quiz you on that or anything. We're really going to focus on the coordination compounds and the complex ions. And that will be the next video.